Welcome to the Dome9 Security Bytes webcast. The topic for this webcast is hardening S3 to prevent data exposure. Our speaker is Feintuch, CTO and co-founder of Dome9 Security. If you have questions about today's webcast or would like to learn more, please drop Roy a note at roy@dome9.com. We welcome you to check out other live and on-demand webinars offered by Dome9 at dome9.com/webinars. You can also sign up for a free trial or schedule a one-on-one demo of the Dome9 Arc platform by visiting our website at https://dome9.com. Without further ado, please welcome Roy Feintuch.
Yay. Thank you, Sudha. Okay, so the topic for today, as Sudha presented, is detecting and protecting against compromised or exposed S3 buckets. So this topic is actually very relevant. Just a few days ago, we heard about an incident with Booz Allen Hamilton contractor, an engineer that exposed some very confidential data via exposed S3 buckets. So the focus for our talk today and the threat model that we're trying to protect against is protecting our S3 buckets from vulnerabilities due to misconfiguration. That means misconfiguration could expose our private data to be read or tampered or deleted by anyone in the internet. So this is what we're trying to accomplish. The way to actually protect something is not just poking with security configuration, but is to actually imagine the scenario that we want to protect against. So again, misconfigured S3 bucket that is somehow exposing our precious data to the entire world. So, before we start, let's kind of review some of the configuration planes, the configuration options of S3 buckets that might have relevance to our topic. The first one that seems relevant is the life cycle of the bucket, but that actually has nothing to do with the access control of the bucket. It's more about the data retention and stuff like that. So it's not relevant. Another configuration that seems relevant is website. As you know, S3 buckets can create or can expose a publicly facing website, static website. But even that configuration by itself is not enough to expose our data. You need to actually misconfigure your data exposure, and then the website will just make it a little bit more accessible. But that control by itself cannot open my data to the universe. Another important but not for our topic configuration property of S3 is the versioning. The versioning configuration can help with all sorts of tampers and can help us mitigate some issues, but these issues do not relate to having our data exposed. So this is an important and sometimes relevant for compliance reason, but this is not what we're looking for. Another proper security configuration that seems maybe relevant, but it's not relevant to our use case, is the CORS configuration. That configuration can control CORS across origin requests for static websites that are hosted within S3. So it is not relevant to the things we're trying to protect against. Last configuration option that is relevant, but we're not going to emphasize it so much in this session, is encryption. And encryption in S3 can vary from server-side to client-side encryption. It can be, you can use Amazon-provided keys versus customer-provided keys. This topic is actually interesting and relevant as itself. My advice, and I will reiterate that in this session, is to invest the time to learn about S3 encryption options. But some of these options by themselves, for example, server-side encryption, will not help us to protect against what we're trying to protect now. Even if the data itself is stored encrypted on S3 buckets, and I'm now referring more to server-side encryption, it will not prevent an unauthorized user accessing our data due to misconfigured access control. So with that, let's try to focus on what is relevant for our challenges. The first access control that I would like to address is AWS ACLs, S3 ACLs. This is the original access control method that was there from the first days of S3. That specific control was designed in the days where XML was cool, but now it's kind of advertised as the legacy method. Still, there are several use cases that can only be addressed or answered by ACLs. ACLs, some few notes about it. So ACLs can be applied to buckets, and not only to the buckets, but also to the internal individual objects, the file, the folders structure inside the bucket. ACLs also can grant permissions to users in other accounts, which is something that can only be done using ACLs. The second access control that I would like to address is the IAM policies. This is the near JSON-based AWS policy language that can be applied in multiple ways. IAM policies can be assigned directly to an S3 bucket, and this is what it's called a resource policy. And IAM policies can also be attached to IAM entities, our users, groups, and roles. So two ways to place that policy, and actually each of them has its own kind of pros and cons. Sometimes you really want to put a policy that is assigned to the resource that you want to protect, and sometimes you want to have a more kind of a different approach where you define the users and groups in your organization, then assign the relevant permissions to them. So so when to use each method? So our first dilemma is whether to use resource-based policy versus IAM or IAM entities, user-based policies, and this is the main dilemma here. My advice, as we have seen much more, I have personally seen much more of the cases of hey, which kind of assets can be accessed by this user? For example, a third-party user that is defined in my environment, in my AWS account. Or this user can access. And that is, imagine answering this question by just looking at this user or this role and examining the IAM policy of that user, and then understanding the capabilities. On the other hand, imagine you kind of sifting through all your buckets and other resources in your system and trying to review the asset-based, the resource-based policies, and trying to understand, hey, does that user have access to that, I don't know, that resource? That could be super challenging. So the advice is to use positive policies that are assigned to IAM entities. And by IAM entities, again, I'm referring to users, groups, and roles, but you don't really want to have IAM policy assigned to users, so we're talking about user groups and about roles that are more oriented for machines or users coming from other account or some other federation methods. So but when to use resource-based policies. And resource-based policies, the recommendation is to use them for kind of negative security, or for kind of governance and protection scenarios. For example, you'd like to maybe you have a super secret S3 bucket and you want to restrict it maybe to be accessed only from assets from a specific IP address, or maybe the CIDR of your VPC, or maybe you want to explicitly deny all the users but that user group. So even if you have some misconfigured user or misconfigured user group, they will not be able to access it. So kind of to summarize it, use positive security as an IAM, restrictive policies as resource policies at the bucket or resource level. So that was the main dilemma of resource-based policies versus IAM policies. Once you clear that, then there is the dilemma if to use the ACLs or the IAM. So again, if you decide to go for IAM policies, then there is not much dilemma here because ACLs are not relevant. If you decide to go for resource-based policies, then still my advice is to go with the more modern IAM policies and use ACLs only when required. For example, allowing users from different accounts. Okay, one last a bit confusing details is the concept of bucket ownership versus the object ownership. So as I mentioned before, at least for ACLs, it's not relevant for IAM policies. ACLs can be assigned not only to the bucket, to the container, but also to the underlying objects. So you could have configurations. Frankly, it's a bit difficult for me to really understand those scenarios, but you could have scenarios where you control the bucket and you're paying for this bucket, but these objects inside, you might not have permission to review them, to get those objects. You might not even have the permissions to review the policies of those buckets. So you don't even know if they're exposed or not exposed. That sounds a bit crazy, but that is possible. You can have this kind of combination where you are not the owner of those objects, and also you do not have permissions to review them. So that kind of adds up to the complexity. The environment, the scenario, and the configuration plane. Let's try to have a work plan how we're gonna fix our stuff. So we have a 4 steps kind of plan. First, and maybe the most important step, is the assessment. Let's understand our existing state. Where are we right now? What parts of my environment is exposed? Then we'll actually fix those things, fix those issues. We'll set proper policies in place. Next, we'll try to prevent future stuff. After we establish a good, solid kind of situation, we'll try to prevent future misconfigurations, and we'll also set up the relevant monitoring to maintain this visibility and control into the future. Okay, first and most important, assess what's my existing state. Now this is I'm gonna use for this kind of assessment. I'm gonna use a technology created by Dome9. Or a language called by Dome9 called GSL, Governance Specification Language. This is a technology which provides us a way to assert, to verify various cloud properties. Everything I demonstrate now can be implemented using whatever programming language you like to use. You like to use Python and Boto, you're more than happy to write the same script using Python and Boto. It will probably be much more complex. So this is why I'm using this syntax. It's much easier to understand. So in order to understand what's my existing state, let's write this kind of a query. S3 bucket should not have now the ACL grants contain this kind of a URI. I'll talk a little bit about it. Or the policy statement that contain this allow effect, the effect allow, and principal is asterisk or principal.aws equals asterisk. And what does it mean? First, we're verifying against, we're checking those, remember those two vectors of configuration for access control, right? We've got the ACL world and we've got the IAM policy world. So the IAM bucket policy. So first we're checking that the ACL do not contain anything like the Amazon.com groups, global, all these kind of global groups of AWS. They have multiple groups. So we're verifying that our buckets do not have these kind of ACL configurations. And then we are looking at the policy, IAM policy level, and verifying that no one has put an allow statement for either the asterisk, which is the anonymous user, or principal.aws equals asterisk. And that's actually something that is not, a lot of people are confused with that. Many people think or believe that if they allow only AWS user, it means that they are AWS users from their own account. So if I allow Amazon AWS user, I'm allowing my AWS user in my account. But frankly, it means that every logged in AWS user to any arbitrary AWS account can access those files. So let me run this kind of query against the engine. Oh, I've got it here. So S3 bucket should not have this thing, and now I need to log in probably. Hold on a second. And let's test it against my production AWS account. And I can see that I have 4 non-compliant buckets. So the system now ran this query against my production account. It tested 20 buckets, and I can see 4 buckets that do not comply with that. So these buckets are actually right now exposed to the world. So I can drill down. It's not that relevant. I would like to show you actually something. So let me connect to this management console, and I'm in this config bucket, which for some reason has opened it to the world, and I can see that any authenticated AWS user can read and write this data, which is not so cool. Let's actually test that. I will switch. I'll switch to my terminal, and let's take a look at the objects there, and I can see that I have this secret file over here. So let me switch to my terminal, and I'm using the AWS CLI with some extra thing. You see this no sign requests. This means this is an instruction for the AWS CLI to not embed my authentication information. So this is actually how people, unauthenticated AWS user, will see my environment. So I'm trying to, this is actually a trick to read the file and copying it to my console, and let's try to see. And you see, I see the content of my super secret secret.txt, which is my secret password. So right now I've got assets which are which could be compromised, which are vulnerable to anyone attacking them or at least reviewing them. Okay, let's continue. The next step would be remediation. And if you follow my recommendation, and you've aligned with IAM-based policies. So the idea is first to remove all ACA-based rules, and then to create the least privileges IAM policies and assign them to your users group. Now that's easier said than done, right? Because now it's actually the work that we work with our users, work with our groups, and understand which user and which user groups or which role needs access to specific assets. But that is a very, very important work that helps us define our policy regarding access to S3 bucket. AWS services can help us with that. So so there are several services that AWS provide which can assist us with this task. So one of them is the IAM service. They have a service last access report, which tells per user, per service, which services that IAM entity has used, what is the last time, and there's also the S3 object access logs that could determine. We can use that to determine the usage. So again, AWS can help us with that, but there's a lot of work that we need to do in order to manage and properly define our system. So once we're done with that, let's just verify that our ACL do not contain rules. So, oops, let's run this query. Okay. Oops, this is not it. Copy the wrong stuff. This is what I'm trying to copy. Okay. S3 bucket should not have ACL grants. Here in this case, I'm actually allowing my root username, which in my case this is the root username. I'm allowing that because this is the root user, and it's okay for the root user to have ACLs, to have access. If you're more than welcome to delete that. If you delete that, there is a weird kind of a weird situation where the root user cannot access his S3 buckets or the content of the S3 buckets, which is kind of an interesting thing. So it needs to have this grant in place. Although, as a best practice, you should not use the root user in order to get access to your Amazon console or to your data. So whatever you wish, you can have it. So in this case, I see that I have 6 buckets that contain ACLs. Some buckets, some of them are buckets that we've detected before, problematic ones. Some of them are again, buckets that contain some ACLs that probably do not expose me to the rest of the entire internet, but still we have aligned with the IAM policies. That's the second thing. Okay, after we did this hard work, now it's time to prevent stuff. And the idea is like that. The IAM policies, by the way, unlike the ACLs, allow us to have deny rules. This means that we can use this deny rule, these deny rules at the bucket level to act like an IAM firewall. So imagine we have at the bucket level a strict deny rule that prevents unauthorized users, and then the internal objects inside, I don't really care about their configuration, even if they're misconfigured. You know, we could have thousands and thousands and thousands of folders and objects, and you don't really care, even if they're misconfigured, because you've put a strong guarantee in one place, which is the bucket. So this kind of prevention technique is something that, frankly, I didn't see that anywhere detailed, and this is something that we're trying here. This is not 100% bulletproof that can provide you these guarantees against any sorts of misconfiguration, but it can protect you against unauthorized access to your content. So let's see what we're doing here. We're gonna deploy this IAM policy. We're basically, look what we're trying to do. We are putting a strong deny policy that will win over the allow that the objects themselves might have, the allow policy. So the effect is deny. The principal is asterisk, which means any user including the anonymous users, and the action is S3 whatever. The resource will be my bucket, everything inside my bucket. And this is where the trick is that we're assigning that policy, we're putting a condition. So that policy only applies for requests that do not have this AWS user ID. Means it is null. It is true that it is null, that these users do not, these requests do not contain this AWS user ID. Basically, that condition means that this is an anonymous call, just like the ones I made using this no sign URL. So let's see that in action. Let's see that in action. And actually, I want to show you that how. So back to my precious bucket. Now, if we examine the permissions of this bucket, let's remove these policies. Okay, so let's clean this bucket. So now it does not contain ACLs. So now this bucket does not contain ACLs, and I want to test again. Let's clear this thing. I want to test again this request. And again, I see my secret password. Why is that? That's because I have a misconfigured object inside my bucket. So let me take a look at this object, and I can see that that object has the permission. Remember that object can have ACLs. So someone has provided everyone read-only access to this object. So even though I did not allow it at the bucket level because the object is misconfigured, I'm doomed. But again, now this policy, the Dome9 or this firewall policy, will hopefully protect us. So I have a copy of it here. Again, remember deny asterisk. For this bucket, for null user ID, anonymous users. Let's put that in place. Permissions, bucket policy. Let's put that in place. Save. Okay. So now I've put this firewall policy in my bucket, and I hope that now my misconfigured objects are protected. So let me try that again. And again, no non-signed request to this bucket. And woohoo! So you can see download failed, action forbidden. An error occurred when calling the other object, operation forbidden. It means that our firewall policy actually works. Now, that, as I said, will not protect us from everything, because that only protects us from anonymous access to our users. If, for some reason my buckets are allowing, sorry, my objects are allowing authenticated AWS users, then we need to make this bucket policy a bit more complex. So I'm actually working and trying to work with some nice folks from AWS to try to have a kind of a more comprehensive IAM policy. So if you're an IAM policy ninjas and you understand how to write this kind of condition that will maybe whitelist only specialized AWS accounts, something like that, please ping me. I can tell you in advance that it is somewhat complicated because there are multiple ways where users can connect, sometimes federated via Active Directory, sometimes federated via AWS account. And so it is a bit complicated, but I'm looking for your nice, good insights on that. Okay, the last piece is monitor. Okay, we got into a good place. We find out all our exposed assets. We cleared it up and set right, correct IAM policies. We even added some protection, so if someone messes with my objects ACL or they are misconfigured, I will protect against some of those misconfigurations. And now it's time to put monitoring in place to make sure that we're gonna keep secure. So we'll use the native AWS tools to do so. We want to detect new assets, new S3 buckets, and make sure they have the relevant correct policies. And we would like to track the policies of the buckets or the policies of the IAM users in my environments. And if someone messes or changes the S3 object access policies, it states new ACL policies. For that, AWS provides us several ways. So first, there is the S3 access policy, these S3 access logs that helps us understand some stuff. And they also connected that configuration with CloudTrail. So CloudTrail, in addition to Trail to audit all my configuration changes, now also allow us to get S3 object level API activity tracking. So I can track those S3 object access via the CloudTrail, and of course use the CloudTrail itself to track my IAM users, my policies, my S3 permissions, all this kind of stuff. So you can hook this CloudTrail information, either create an alert within the AWS system itself via CloudWatch log alerts, or connect it to your SIEM system and then alert on that. Okay, a few last notes. While this is, again, out of scope from this talk, encryption is an important measure. Done correctly, client-side encryption, customer-managed keys might prevent your data from being exposed, even if somehow the bucket itself or the object is misconfigured. So if someone gets data and this data is encrypted, then that will prevent, or that is encrypted using a customer, using your own keys, rather than the default AWS keys, then that will prevent the user from reading it. So I suggest to research the relevant right type of encryption and use it. Another question is what to do with buckets that should be public, and sometimes the S3 buckets really needs to serve public content, right? We're internally in Dome9, we're using that to host some public sites. We're using it to host some Linux repositories. So, so my recommendation here is two things. Maintain consistent naming policies. This is the first thing. You want to get into a situation where a human being looking at the bucket and knows immediately that this is a public asset, right? So probably embed the public, or I don't know, all access, or whatever that makes sense for you guys or your own language, and make sure that each public bucket that should be used for public access has this kind of very clear notion of a public prefix or a suffix or something like that. That's for the human beings. For the machines, I would like to have even something more well-defined. So S3 bucket supports tagging, so you can use the AWS tagging and put some, I don't know, public equals true or some kind of a tag, a well-defined tag that will allow you to with your software-defined verification. Remember all the tests that we did before, so you can now exclude the buckets that contain is public equals true in the tags, this kind of stuff. So this is my recommendation, first for the humans and then for the machines. Have some consistent policies. I would also would like to thank Scott Ward from AWS for helping with this peer reviewing this content and providing some great ideas. So thank you, Scott. And thank you all for spending the time with us, learning a little bit about S3 bucket security. Thank you.
Let's see how this sounds. Where the fuck did that truck come from? I mean, oh, we're recording again.